Think about a fireworks display. Everyone can enjoy it without reducing its availability to others, and no one can be forced to pay. This is a public good, non-rivalrous and non-excludable. But because people can benefit without contributing, markets often lead to underproduction of public goods, leaving society worse off. In this video, we'll explore why this happens and what can be done to ensure public goods are provided efficiently.
In this video, we'll talk about public goods. Now remember, public goods are things that are non-rival in consumption, meaning multiple people, or maybe even everyone can benefit from that same unit that is produced. It's not like a cheeseburger where if one person eats that cheeseburger, another person can't, right? So this is gonna be non-rival in consumption, and these things are non-excludable. The non-excludability is gonna be very important here because this is gonna be a case where a private company going to be like, if you don't pay the price, you can't benefit from it. And so that's going to lead to problems, this non-excludability here. In particular, the problem we're most worried about is called the free rider problem. All of you have experienced the free rider problem in many different guises over your lifetime. And so the essence of this free rider problem is that someone can enjoy the benefits of a good without bearing the costs or paying their fair share. Right? So just think about group work in teams. If somebody works really hard and puts in a lot of effort in this group work, some other member of the group can just shirk their work and not put any effort and still get a good grade on the assignment. All right, that's a prime example of a free rider problem because you can't exclude somebody if you're working in the group, and it's non-rival, that group grade, the effort you put in. Okay, so we're going to look at this free rider problem in more detail. What the problem that this free rider problem is going to cause is that public goods tend to be underprovided by the market. So a private market were to provide a public good, you'd have underproduction, right? And that's going to lead to a market failure here for public goods whenever we have these non-rival and non-excludable goods. I'm going to go through the classic example of a public good, which is going to be a lighthouse. So this is what Adam Smith back in 1776 in The Wealth of Nations, talking about this example. He was talking about lighthouses as a public good. So is a lighthouse non-rival, meaning if one boat sees the light that's going around in the lighthouse, does that prevent another boat from seeing that same light? No, many boats out at sea can see that same light and make sure don't go that way or we're going to run into rocks, run into the shore. Is it excludable? So what excludability would look like here is like the owner of this lighthouse, which say these ships, well, if you don't pay like a membership fee to use our lighthouse, you can't look at the light when you're out there. You can't benefit from it. How is that going to work? How is an owner going to say, like, don't look this way, boat captain? You didn't pay your price, right? It's not going to happen. It's very difficult to exclude a ship if they haven't paid the price to look at your lighthouse. And so this is going to be non-excludable. So we have a non-rival and non-excludable good. A lighthouse is a classic example of a public good. So I'm going to go through a simplified example here of a lighthouse and trying to convince you that this public good of a lighthouse will be underprovided by the market. The following table is going to show you the marginal benefits for 3 ship captains who receive for various numbers of lighthouses along a coastline. Right. So we have Captain Ahab here. Captain Ahab's marginal benefit of no lighthouse, let's forget about that one. Captain Ahab's marginal benefit for the first 10 lighthouses is 220. For the second 10 is going to be 200. For the third 10 is going to be 140. For the fourth 10 is going to be 100 marginal benefit, right? So as you increase the number of lighthouses on the coastline, Captain Ahab's marginal benefit goes down, 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 diminishing marginal returns. Diminishing marginal benefit. Captain Bligh has going to be less marginal benefit than Captain Ahab, but again, it's diminishing. Captain Nemo, 10, 20, 30, 40 lighthouses. Again, a little bit higher than Captain Bligh for a while, but then it's going to decrease and diminish marginal benefit. Okay, the marginal cost of a lighthouse owner to produce a lighthouse is $220 per lighthouse. Okay, now we want to go through an example if lighthouses were a purely private good. This is if you have a private owner of the lighthouse and they're trying to charge fees or a price to each of these captains to try to get them to provide money to build this $220 lighthouse. Okay, so we want to think like if that's the marginal cost, here's our marginal benefits. what's going to be the total number of lighthouses that these three individuals would demand and be willing to pay for if it's this purely private good at a price of $220. So what we want to do for a purely private good is within each of these captains, we want to compare marginal benefit to marginal cost for each captain. So Captain Ahab will buy that number of lighthouses only if that marginal benefit to them personally is greater than or equal to the marginal cost or the price of $220. So we want to compare this line here, those first 10 lighthouses for Captain Ahab. Is he willing to pay that $220 price to get those first lighthouses? Yes, because the price of $220 is greater than or equal to the marginal benefit is greater than or equal to the price of $220. So we'll say yes, yes. Do we want to do any more? So the second 10 for a total of 20. Well, now the marginal benefit's only $200. So it doesn't make sense for Captain Ahab to pay a price of $220 if he's only going to benefit by $200. And so Captain Ahab says, nope, not going to buy that one. We'll stop there. Not going to buy any of these either. All right. So Captain Ahab's going to pay for 10 or demand 10 lighthouses at a price of $220. Captain Bligh, compare these marginal benefits to 220. All of them are lower. And so Captain Bligh's like, that's too high of a price. I'm not going to buy any lighthouses. Right? So Captain Ahab says, I want to buy 10. Bligh says 0. Captain Nemo, compare Captain Nemo's marginal benefit to 220. Marginal benefit's lower than the price, lower than the price, lower than the price. Captain Nemo's not going to want to buy any either. Right. Done. So Captain Nemo is going to pay for 0 lighthouses. So in total here, the marginal cost of production of 220. If a private market we're going to try to provide this good and charge prices for it, they would only sell a quantity of 10 lighthouses that would be provided by a market. Okay. So what I mean by market here is like if a private individual is like, I'm going to buy a lighthouse and try to charge people prices for it, I'm only going to be able to sell 10 lighthouses and build 10 lighthouses, okay, for that market quantity. Now, if it's a public good, we want to try to find the efficient amount here. What's the efficient amount of lighthouses? And because it's a public good, it's non-rival. And so all 3 captains can benefit from that same lighthouse. Okay? So we want to add up the total marginal benefit across all captains and compare that to the marginal cost. That's going to give us the social marginal benefit. So what I mean here is we want to add up 260, 120, and 150, 220, 100, and 120. So for the first line there, we'll get 530 marginal benefit, right? So this is total marginal benefit across all captains, summing that up. Right? The second one is going to be 440 when you add those numbers up. And what that 440 means, in total benefit from building 10 lighthouses is actually 440. 220 comes from Ahab, 100 comes from Bligh, and Nemo benefits by 120. So in total, society is benefiting by 440 for that first 10. If you add up the second 10, you'll get 370. For the fourth 10, you'll get 260. Then it's 170, 80, 20, and 0. All right, so to find the socially optimal or efficient quantity, we want to compare this total marginal benefit summed up across all individuals and compare it to 220. This is only what we do, this summing up across individuals. This is only happening for a public good because it's non-rivalrous, right? Everybody gets to benefit from it, for it, okay? All right, so now we want to compare 530 to 220. Well, 530 is greater than 220. Buy those first, the 440 is greater than 220. Buy those first 10. Buy those second 10. Buy the third 10. Oh, stop here. We only benefit, or society only benefits by 170. The cost is 220. Don't provide that one. Don't do that one. Don't do that one. Don't do that one, right? All right, so we're going to be on that row there. And so the socially optimal efficient amount will be 30 lighthouses. So the efficient amount of lighthouses is going to be 30. Private market, if you're going to try to do this from the previous slide, would only provide 10. And so this is why we have this underproduction of a private market for a public good. Right? Socially efficient is 30. So what happens then, one potential solution that I'll go into here in a second in more detail, is maybe the government should provide these lighthouses and just start taxing ships. All right. So like ideally, it would be like a government bureaucrat would say, like, okay, they have all these numbers. Like, oh, the socially efficient number of lighthouses is 30. We need to go build 30 lighthouses. We need to go get enough money to build 30 lighthouses and then start taxing these ships when they come into port, right? So it'd be like, oh, you come into port, you got to pay us a certain amount of money because we know you benefited from those lighthouses along the coast. And that's how they could gain revenue to pay to build these 30 lighthouses. All right, so a solution, like I alluded to before, would be government support for public goods. So national defense, public good, non-rival and non-excludable. And so we have a government that's going to fund it, and then the government is also going to provide national defense. Right? The heart of the free rider problem is that businesses can't force people to contribute toward public goods that they benefit from. But the government can solve this problem by forcing everyone to pay their fair share through taxes. So this is what the U.S. federal government does. They tax their citizenry and use that tax revenue to provide and fund national security. All right, the other one is like scientific research and creation of knowledge. Everyone gets to benefit from that. It's hard to charge someone a price for that. And so the federal government is going to fund it. They'll collect taxes from the citizenry, and they'll provide funding for it. So sometimes the federal government is providing the research, and other times like universities or private companies will be providing the research, and they'll just get money from the government. National Science Foundation grants, grants from the Institutes for Medicine would be providing. National Institutes for Medicine or Health would be providing grants to universities to do this. All right, so 3 facts to sum up about public goods. Fact 1. Just because the government provides something, it doesn't mean that it's actually a public good in terms of the definition that we use here in our economics class. The government provides many goods that are not public goods. Examples, mail, buses, trash pickup. You could exclude all people from all this, right? The mail, right? If you don't pay your postage, we're not going to deliver your mail. That's excludable. Buses, if you don't pay your bus ticket, buy a bus ticket, you don't get on the bus. Excludable. Trash pickup, if you don't pay the trash company, they're not going to come pick up your trash. Right? So all these things are excludable, even though governments tend to provide them. So there might be other reasons why government provide these. We don't need to go into those now. But what I want to get across here is just because the government provides it out in the real world doesn't mean it fits this public good definition of what we want to use in class. Fact 2, just because something is a public good doesn't mean that the government should fund it. Right? So what this means is that the government needs to do a cost-benefit analysis to see if they should actually fund this thing. So all those lighthouses before were public goods, and we decided that the number of 30 lighthouses was the socially efficient number. So what this means is 60 lighthouses would also be a public good, but 60 lighthouses doesn't pass a cost-benefit test. Right? They shouldn't do 60 lighthouses. They should only do 30 lighthouses. And so what this here is we still got to do our cost-benefit analysis to decide the socially optimal quantity, even if the government's going to fund something. And finally here, fact 3, just because the government should fund a public good doesn't mean that the government should provide it. Okay, so public goods will be underprovided in the market. And so an example here is going to be a fireworks display on July 4th. Right? It's hard for a private firm to charge someone to not look at their fireworks display on July 4th. So lots of times governments will provide, like city governments will provide and fund the fireworks display on July 4th. So governments will be collecting taxes and pay for it. But what they'll do is they're going to hire a specialized firm that specializes in fireworks, setting off fireworks, to go actually run the show. So the idea here is the government collects taxes to fund it, but they're going to contract out or hire someone else to provide it. Some individual who specializes in that activity.